In this video, we're going to continue our exploration of kinematics in one dimension. That is a unit that has to do with things like distance, velocity, acceleration, and time. In this particular video, we're going to study what is the average velocity and what is the average speed, and how to calculate both of them. We're going to learn the formulas for both and solve 2 to 3 practice problems, practicing how to apply these equations. So let's start with describing and talking about the formulas for both average velocity and average speed. If you have watched the previous video, you should probably already know the difference between a vector, a quantity that can have a magnitude and a direction, and a scalar, something that can only have magnitude, no direction. Average velocity is going to be a vector, meaning it's going to be delta x over time, or displacement divided by time, versus average speed, which is going to be distance traveled divided by time. Now, if you've never seen these formulas before, it might look to you as if displacement and distance traveled would be the same thing. However, if you watched my previous video, you saw that in a lot of examples, displacement and distance traveled have different values. Therefore, if you haven't seen it yet, watch the first video. If you're coming from that video, let's keep working through this. We're also going to be learning the formula for average acceleration, which is change in velocity over time. Acceleration is always going to be a vector because it will always have a direction. Now, let's take a look at some of the problems that we have here for average velocity. Here we have Bob and his trips. So Bob drives 120 kilometers from city A to city B in 2 hours. 120 kilometers in 2 hours. Then he returns back to city A, taking 3 hours for the return trip. Calculate, which is also 120 kilometers. Calculate Bob's average speed and average velocity for the entire trip. So let's start with average speed. So average speed, as we saw from the previous page, is going to be total distance traveled over time. Now, what is the total distance traveled in this case? He goes 120 kilometers to the right and 120 kilometers to the left. So it's just going to be 120 plus 120 divided by the total time, which is 2 hours plus 3 hours for the return trip, or 240 over 5, which is equal to 48 kilometers an hour. Now, what about the second part of this question, which is the average velocity? Now, average velocity is going to be displacement over time. Let's remember, what is the displacement in this case? If he starts here and ends here, his displacement is going to be 0 because he came back to the same exact point. Remember, the displacement is the distance that your final point is minus your initial point. If you started exactly where you ended up, you're the distance of 0 from your initial point. Therefore, displacement is 0. So 0 divided by 5 is going to be 0. A lot of the times, there will be a different value for average velocity and average speed. So always make sure that you use these particular formulas to calculate them. What would have been wrong to do was to find velocity for this part, find velocity for this part, and then try to average them together. Never simply just average these two values. Always use the formula. Now, let's take a look at the next example. Here we have Chris, who embarks on this journey on a round trip by bike on a circular track with a circumference of 15 kilometers. So basically the distance is 15 kilometers, and he starts here and he ends here. He completes the first half at an average speed of 10 kilometers an hour. Okay. And the second half at the speed of 15 kilometers an hour. That is, the first part of the journey is going to be 7.5 kilometers, and the second part of the journey will be 7.5 kilometers. Calculate Chris's average speed for the entire trip. Now, the maybe more intuitive part would have been to simply average these two values, 10 plus 15, and divide them by 2. But remember, don't ever calculate average velocity or average speed by simply averaging velocities together, meaning 10 plus 15 divided by 2. Don't do that. We will still use our formula where average speed is going to be total distance traveled divided by total time. Now, of course, we don't have time in this case. Let's calculate the time that it takes to basically cover the first and the second half. Now, distance is equal to velocity times time. So time is going to be distance over velocity. Meaning you can calculate the time here, which is going to be distance, 7.5 kilometers over 10, or 0.75 hours. And you can calculate the second time right here, which is 7.5 divided by 15, or 0.5 hours. Therefore, the average speed, attention, is going to be total distance, or 15 kilometers, divided by total time, 0.75 plus 0.5, or equal to 12 kilometers an hour. Great. Hopefully that made sense. Now, I want you to think by yourself about part B. What is his average velocity? Remember that average velocity has a formula of displacement over time. If he started here, completed one full circle, what is his displacement? Just like in the previous problem, his displacement is 0 because he ended up at the same exact point where he started. Therefore, average velocity is going to be 0. Great. Now, we're not going to do the average acceleration for this case because, again, average acceleration, of course, is going to be change in velocity over time. Since the change in velocity is 0, right, the average velocity is 0, then acceleration is going to be 0 as well. But we're going to skip this part right here, C. Great, let's take a look at part 3. This last problem for today is going to be talking about a train. A train travels 160 kilometers north in 2 hours. And then, so north, and then 240 kilometers east in 3 hours. Calculate the train's average velocity and speed for the entire trip. Now, average velocity first. Average velocity is simply going to be first distance plus second distance over time plus the second time, or 160 plus 240 divided by 2 plus 3, which is 5, and overall is going to be 80 kilometers an hour. Now, let's take a look at the average velocity. Of course, I had to include at least one problem where average velocity is not 0. This is going to be one of those examples. The train goes 160 kilometers north and 240 kilometers east. So if we're calculating average velocity, which is displacement over time, the displacement is going to be the initial point to the final point. So this distance right here. Just like we did in the previous video, we can use Pythagorean theorem to figure it out. 160 squared plus 240 squared. Or take a square root of both sides, which is 288.4 kilometers. Perfect. Now, we can plug this in back into our equation. The displacement is 288.4 divided by time, which is 5 hours, and the average velocity is going to be 57 kilometers an hour. Great. Now, in the next video, we're going to be talking about relative velocity. We will very briefly discuss this concept and solve a practice problem that has to do with relative velocity. Thank you guys for watching. Keep practicing and keep watching these videos on your way to an A. Thank you.